How's it going, guys? My name is Mark Valentino, and I'm showing you a project I've created called Sacred OS. Sacred OS is a virtual web operating system that runs in your browser. And this is like, a regular operating system where you can run programs, you can manage files, like deleting files, renaming files, making folders, etc. Like this does that, but on a web page. Um, as you can see right here, I'm on the boot screen of Sacred OS. You can boot from several different options. You can boot from local storage, which is where the browser saves data to using JavaScript. So you can like save your data and go back to it with this. Similarly, I have the boot option of booting from a JSON disk backup. What this does is it allows you to boot from a file, like a JSON file. So if you wanted to use Sacred OS on a different browser or on a different computer, you can go into your original Sacred OS installation. You can create a JSON disk backup, save it to your computer, your real computer, and then go into your other browser and upload it here, and we'll boot from that. And we have fresh install. What that does is what the name implies, is it just creates, it compiles OS from various files and puts them in a JavaScript object, which is basically what I call a virtual hard disk, and it will boot from that. So right here we have system checks. These are more for fun, but it will tell you if the browser you're on or the device you're on can even properly run Sacred OS. Like if you're on mobile, it will tell you the screen resolution is not supported. It will tell you not having a mouse or trackpad is not supported. If you're on a different language, it'll tell you it doesn't support that language. Yeah, I don't know why Chrome is set to English Great Britain, but it is. So I'm sorry, people in Great Britain. I might be misspelling color. I'm not including the U in color. But yeah, this is the boot menu. I have it enclosed in an actual, computer monitor. Actually coded this with CSS and divs. You can tell I'm pretty good with front end development. This monitor is not an image or an SVG. It's just actual divs with like gradients and shadows. But yeah, let me go over the code. So what I'm going to do is I'm going to do a fresh install. And when I do a fresh install, it's going to print in the system check area the files it has loaded and installed to the virtual hard disk. So let's do it. Now let me show you what's going on in the code. Well, maybe I should just show you the operating system first. But yeah, a bunch of files were able to make this thing happen, Uh-oh. That's... There's a bug. I promise you that works correctly in Firefox. Hold on. Yeah. Yeah, that's something I gotta fix later. But anyway, So a bunch of files make up the actual operating system. And as you can see right here, all these files like the GUI.css, GUI.js, all the programs, they are different files that are fetched and put inside a virtual JavaScript object. And so this is kind of unusual. You know, most people, when they're making a website, they will just use anchor tags to go to different web pages and different files. But with this, I'm actually loading everything up all at once. So right here, the file table, it contains all the files you need to run the OS and install it. And the structure of this, structure of the file table is a nested JavaScript object where the arrays are folders, excuse me, and you can have nested folders like right here, like document.json, that's an icon which is inside system. Yeah, so these files are actually publicly accessible. Like you can actually go to right here. So this is programs. This is in the programs directory, which is nested inside the default directory. And this is called settings.html. NeoCities trims off the file extension at the end because I think it looks nicer. And here's settings.html. As you can see, it's inside the programs folder, which is inside, well, it's inside the default folder, which is inside the programs folder. And you can see that same program right here in the operating system, settings.html. As you can see, it looks a little different because there's other stuff going on in the background, which I'll get to later. Okay, so anyways, how does this thing actually install the OS? So this file contents its actual virtual hard drive. It's in a var. Just because scripts dependent to the DOM need access to it. You know, typically using var is a no-no, but yeah, I kind of did some crazy stuff to make this thing happen. So what you can do right here, this is if you want to upload a JSON disk backup. This is where the logic of that happens. This is what happens if you boot from local storage. Let's see. So it's been a while since I've looked at this code. I believe default settings is where you're actually doing a fresh install. I should change this for better code readability, obviously. So what this is doing is it's loading the contents from the file table. Yeah, this has to be doing a fresh install. So what it does is it loads contents from the file table and it passes in this file table object, and we have a default file contents that's just temporary because this is an async function. then it finally sets the actual hard drive to the loaded file contents, and then it does some code after the file content has been loaded, which is actually booting up the operating system. So let's go to the load file contents. So with the load file contents, this is a recursive function that allows us to iterate through this nested structure. You know, if you think back to, you know, a data structures and algorithms course, you're taught how to iterate through a tree and how you iterate through a tree with nodes. You go through it recursively. And so that is, you'll see that a lot in this code. We go recursive just because of all the nesting. Okay, let's go back to where we were. Okay, so we're in load file contents. We have a base path. And so we, right here, we are altering like the boot screen to just kind of get rid of certain things. Like we're getting rid of the system checks. And so what we're doing right here is we're going through the keys in the file table. The keys are the folders. And then through each key, we generate the file URL. Then we fetch the file URL. Then we print out to the boot screen that we loaded that file. Then we do all kinds of logic to make sure that we don't print too many lines to the screen so things don't overload or overflow, I mean. Yeah, and here if we detect a nested object, we go recursive. And fetch content, this is kind of interesting. For fetching text files, it's kind of your standard JavaScript fetch, you know? We do that for HTML, CSS, you know, just regular text files, you know, and we return we return that text content. But yeah, like in this JavaScript object, we were actually encoding, we were actually putting inside actual HTML files and CSS files inside the JavaScript object. But if it's not a text file, what we do is we do some crazy stuff with binary loading. We make a uint8 array, that's like a binary array, and then we convert that to base 64. I was originally just using binary to encode non-text files, but I was running into some issues. Like I wasn't sure if that was really supported with using arrays, like mixed with you know, regular UTF-8 encoded text and that sort of stuff. So it's safe to encode binary data in base 64, so that's what I'm doing. And I ran into some issue right here is that I could not encode in base 64 all at once. Safari would not allow it. Like the max spread of this function is actually like this number, and so I had to divide that up into chunks. And so at the end, we return the base64 string, and yeah. So we traversed the file table. We determined the URLs to load, and we fetched the content, and we put the text content in the virtual hard drive. And the virtual hard drive follows a nested structure. And so here's what happens after we generated the install. Some of this code I think can be refactored, but what it does is once this right here, the GUI.frag.html, that's the actual HTML file for like the taskbar, the start menu, the clock. And I'm using GUI.frag.html because it's not like I'm using that file extension because it's not a full HTML file. It's just a fragment HTML file. Let's see if I can pull that up. GUI.frag. Yeah, this is it right here. It's just a fragment. And so then what it does, it creates it appends it to the DOM, hides some things, hides the CRT and boot container, gets rid of the boot screen basically. Then it does something similar with GUI.css. It also appends that to the DOM. We also have the kernel.js. The kernel is the actual kernel of the operating system, and it appends that too. Then we have GUI.js, which kind of controls it controls, opening the start menu, the clock, dragging around windows. Also handles a little bit of opening programs. Like GUI.js and kernel.js are kind of related, but those are both scripts. And once the GUI.js is appended to the DOM, we start the GUI in this function right here. GUI start. Let's see if we can open that up. GUI start is right here. GUI start is where like the OS is finally loaded up and booted. And this populate menu populates the start menu with all the programs. This loads the desktop background. This loads the font. As you can see here, we're using like a pixelated font. And how these things work is that they are reading through the user settings, or not really user settings, but like a system settings JSON file. Yeah, see right here, this is how it knows what desktop background to use and how it knows what font to use. So if you know what you're doing in this operating system, you can actually change the font used if you want. You can load up your own custom font. You really don't have to mess around in here to change the desktop background. You can actually do something like this. Hold on. And set this as a desktop background. I thought I would include this in the operating system because it's kind of funny. Any application that can be written in JavaScript will eventually be written in JavaScript, which is what I'm doing right here. made an operating system in JavaScript. But yeah, let's look around more in the operating system. Like, we got a file manager, got settings, which I already showed. You change the theme of the operating system. We got some fun little programs here, like a YouTube filter, which you can paste in a YouTube link and watch YouTube videos with like all these kinds of fun filters.
What are you trying to...
You change the time format. And so this operating system, as you saw earlier, it executes HTML files. And so how it does that is it puts the HTML files in an iframe, which are in turn put inside, a div, which with code that allows you to drag the window around. Like, what's inside this border here, like minus this orange bar, this is like the HTML file inside an iframe, but this is like a div that encapsulates that, which allows you to drag it around, resize it, minimize it. And let me open up a program. So this is files.html. Like, this is the File Explorer equivalent in Sacred OS. As you can see, it's a very large program. But this comment right here, this is data that the GUI uses, so it knows how to handle the program. Like this width and height. This is the default dimensions of the program when it runs in a window. You can change these values right here. Like, you can make this like 300, and it will update that. I'm running Sacred OS locally. Oh, wrong one. As you can see, it makes the program open up a little smaller. And this micro icon right here, this is a base64 encoded PNG. And that is how the GUI knows what to put right here, like start menu, like what the icon is for the program. And so let's go on to the kernel stuff. So the kernel is a really huge piece of Sacred OS. There's a lot of JavaScript code in here. So if you go in Sacred OS, like the styling of the different elements, like the drop-down menus, buttons, like they're similar, or they're the same. I mean, and how it does that is it loads the style sheet from the actual JavaScript object containing the hard drive. Some of you might be thinking, oh, why not just load the style sheet from like a meta tag, like, or no, not a meta tag, link tag. But the reason for that is because this is an operating system, and I want users to be able to control how the styling of their operating system works. So the style sheet code has to be easily updatable. And so in order for the program to load the style sheet, it sends a message to the kernel, which is this right here, this reqss. That is short for request style sheet. And it sends a message to the kernel using the window.top.post message function, and that is used for iframes to communicate with the window.top, which is the parent document. So let's go into the kernel. What am I doing? So the kernel has this huge block of code for the onMessage function, for like receiving functions. For receiving messages, So depending on what the message starts with, it will execute different code. So right here, if the e.data, event.data equals reqss, it should be a triple equals. I don't know why it's like that, but it will load, it will check if the file, the GUI.css is there. Then it will send a message to whatever iframe requests the style sheet, and it will send the style sheet data. So we can go back to files.html. So files, a lot of programs, they have a window.onMessage function too, or windows.addEvent listener. I'm sorry. So it'll listen for a message, and it will be kind of similar. It'll have code similar to the kernel. So right here we have, if e.data starts with ss:, it will extract the style sheet from the message, and then it will append the style sheet to its own DOM. As you can see, we already have styles right here, so it's going to be appending, it's going to be having two style blocks. It has two style blocks because it has styles that really only apply to the files program, so it doesn't make sense to include it in the GUI.css file. But yeah, like if you wanted to like delete files, rename files, make folders, delete folders, you would do that through the window.top.post message function, like right here. This is how you can this is how it's setting a desktop background in its own in the files.html's context menu. Like you can right click over an image file and click set as desktop bg, and when that happens, it sends this message, and then the kernel will receive that, and then it will, what it will do is it will adjust the settings file, the settings.json, which is right here. We'll change this to the new desktop background to show, and then it will also communicate with the GUI to replace existing desktop background with a new one. Yeah, there's all kinds of crazy stuff I'm doing right here. Yeah, I got like a browser right here. This is not very functional. You would think this is kind of easy to implement, since I could just run and web pages in iframes, but modern browsers have put a lot of security restrictions on iframes, so, and also websites have too. So like you can't just go to Google. Oh wait, hold on. Yeah, like Google will prevent you from actually no, it's really Firefox. Yeah, modern browsers like I can't remember if it's the actual browser or the website. I think it's a mix between those two with cores. Like they won't let you display certain web pages in an iframe due to security reasons, because if anyone can display Google in an iframe, they can do all kinds of crazy stuff like I'm doing right here in this OS, and they can make like a fake Google web page with like a fake login function, a fake login button where they can steal your password and email. So I can kind of understand why they would do that, but like the solution around this is to make like a proxy. But I'm not doing that because that's going to cost money, and I don't know about all the legalities around that, but yeah, like the browser in Sacred OS is kind of limited. Like it's basically impossible to get the current SRC of the iframe you're on. Like if I were to see, I'm going to different web pages and the SRC of the iframe is changing, and there's a security feature in JavaScript which prevents you from knowing what SRC you're on currently. I'm not sure why that's a security feature, but it exists. So I kind of have that browser there for fun mainly. Another interesting thing I have right here is an app store. This is how you can install new files. Let me go back to Chrome. Chrome looks a little nicer. Into Chrome, you get little nice scroll bars. Yeah, and Chrome and Safari let you style the scroll bars, but in Firefox you can't do that so easily. You'd have to essentially create a new scroll bar with JavaScript, and most people use Chrome anyway or Safari, so that's kind of why you can only get these nice scroll bars on Chrome. So okay, so anyway, here's the App Store. You got different programs here. Most of them are made by other people. Like Eric Houdini, I know him a little bit. He's also on NeoCities. He offered to put this program in Sacred OS, and so put it in the App Store. This Doom clone, actually just saw this was MIT licensed on GitHub, and so I just decided to stick it in there. Same thing with Canvas Bird. Stephen Blanco, he made a pull request to Sacred OS and merged it into Sacred OS. This is a little program where you can increase your reading speed. It's a pretty cool app. So you can install programs right here, and we'll add them to your virtual hard drive, just like you would expect in a normal operating system. And it creates a little start menu shortcut, and you can see the installed program right here. Yeah, this is pretty incredible. This was made with like 13 kilobytes of JavaScript, I believe. Like this is part of some competition. Like all this, 13 kilobytes of JavaScript, which is pretty impressive. So what else is there? Oh yeah, you can edit files right here. You can go back to the Doom clone. Let's see if we can change the text here, just to prove we can edit files in SacredOS. Hello world. So we saved it. There we go. But yeah, if you want to uninstall a program, you can just like delete the folder contents or file contents. Another funny thing with SacredOS is you can actually delete the actual system code, like, and it will break the operating system. So let me save the session. So I'm gonna go back to where I left off. As you can see, we're back to where we were before. We installed, well, we deleted the Doom clone. But we can delete the GUI, we can delete the kernel, and there will be nothing stopping us. You know, that was kind of lower on my list of priorities, but I feel like leaving that in as a feature is kind of cool. Just to kind of prove that, yeah, this is an operating system. You can actually break like Windows by like deleting System32. So what happens if we delete GUI.css? Let's save the session. Yeah, this operating system doesn't save automatically. You have to manually save it because of stuff like this. In case if you accidentally delete the kernel, you want to probably go back to when it was actually working. Yeah, so this is how it looks when you delete GUI.css. As you can see, it's completely broken. Well, almost completely broken, but oh. But yeah, this operating system, the source code is on GitHub. You can check it out. You can contribute to it if you want to. If you want to learn more about developing for the operating system, I have an incomplete list of kernel commands. Yeah. Let's see. Was there anything else I should cover? Oh yeah, you can actually upload files right here. Let's upload this file. You can actually upload files to the operating system. Like I just uploaded a random screenshot, and you can view it right here. You can basically upload any kind of file. Like eventually I want to give the ability to, you know, run like video game ROMs, like Sega Genesis ROMs or Game Boy ROMs. Have a little emulator. Probably several different emulators. But yeah, just let me know what you guys think of this operating system. Uh-oh. There's a bug. There are some weird incompatibilities. I'm trying to fix. Seems like this is like the worst project when it comes to browser compatibilities. Just because this thing is so unusual and different. Like, okay, making a folder works there. Don't know why it wasn't working in Chrome, but anyway, I hope you enjoyed the project. If you've got any suggestions for new features, or if you want to report a bug, just let me know. Thank you.